Good morning everyone. Today we are discussing on problems of network theorems and basics. This is the sample example. Now in this circuit we need to find the current in our resistor, the current flowing through this circuit in amperes. So to solve this we are using Thevenins theorem. So in Thevenins theorem we need to find one is Thevenins voltage across this resistor. So I am redrawing this circuit. And then it is considered as VTH and a voltage source here, 1 ohm, 1 ohm, 1 ohm resistor, 1 ampere. So to find this, first we assume the current direction. Current I is flowing in this circuit. As it is an open circuit, entire current flows, I current flows here, and after here I current flowing, here 1 ampere is flowing. Output current will be 1 plus I. After this I current will be returned to the source again, and 1 ampere will be divided here. So 1 ampere will be closed here. Now to find the I current we apply a KVL here. KVL across this loop. So starting from here, if you go forward, first sign we have seen is minus 1 volts. Here this is positive sign, negative sign, as this positive is due to current direction. If current entering, that is considered as positive terminal. Here positive, here negative. So the first terminal we seen is positive 1 ampere with I current plus 1 ampere 1 plus I current, and we end up here is equal to 0. So we expand this. So positive 1 negative 1 will be cancelled out, so 2I is equal to 0, and at last I will be 0. So the current I is equal to 0. Now so if I is equal to 0, then if you apply a here we consider this as positive and this is negative, and we will redraw this circuit. As the current in this is 0, so the voltage drop also 0 volts. As the 1 amp is flowing here, 1 amp, and here also the same current is flowing, so it is positive negative, and this is, so if we apply again a KVL in this loop, in the second loop, this is the first loop. So here if you apply KVL here, the first sign we saw is negative of minus 1, current also 1, so negative of 1, current also 1. So here the voltage drop is 0, so it is in positive 0 or negative 0. Next, the first sign we saw in this loop is positive VTH is equal to 0. So minuses, putting VTH in LHS, remaining all are in LHS, the answer will be 2 volts. Now we got VTH is 12 volts. Similarly, we will find RTH value. While RTH voltage sources will be short circuited and current sources will be open circuited. Now as it is a voltage source, short circuit, as the current source will be open circuited. From here we will be finding the RTH 1 ohm, 1 ohm, 1 ohm. As we can see, if we apply a test voltage, then if test current ITH is flowing, then the current will choose a lowest path, so it won't go through the circuit. It will directly go to the started circuit and flows through this. So we can directly say that RTH is 1 ohm. By redrawing the circuit with Thevenins voltage and Thevenin resistors and a load or resistor R, RTH is 1 ohm, 2 ohms VTH, RTH, and RL, R is equal to 1 ohm. So the current flowing in the unknown resistor is, as it is in the series, the currents are same. So total voltage is 2 and the total resistance is 2, that is 1 amp. So here the current flowing is 1 amp, here is 1. Coming to the next question. In this circuit we need to find I1 by I2 current, ratio of I1 by I2. That means in the circuit this I1 current, in this circuit I2 current. This both circuits are same, but the voltage is in the left side for the first circuit and on the right side on the next circuit. According to reciprocity theorem, here V and I will be proportional to after changing the voltage, and this voltage and current will be proportional. So we will solve and prove that reciprocity theorem. By reciprocity theorem, two volts into I1 will be equal to 2 volts into I2. So from this we can tell this as I1 by I2 is equal to 1 amp. We will prove this by solving this circuit. So let's take the first circuit. Current I1 is flowing here. Let solving this by nodal analysis. VA. So let's assume the current direction. I is coming here, I1 is going here, and I2 is dividing here. So I is equal to I1 plus I2. So I will be, as the current direction is from downwards to upwards, it is coming to the node. So 2 volts will be the starting and the next voltage will be the minus. Potential difference means first minus second will be the potential difference. And for I1 will be VA by 4 plus V2 will be VA by 3. So by solving this, 12 3 VA plus 4 VA is equal to 2 minus VA by 5. Cross multiplying, 12 2 minus VA is equal to 5 times of 3 VA plus 4 VA. 12 to 24 minus 12 VA is equal to 15 VA plus 20 VA. Now VA is in one place, so here when it goes here it is 35 40 45, 47, 47A. So VA is equal to 24 by 47. So I1 current will be from this circuit VA by 4. That means 24 by 47 into 4. 4 6 times. 6 by 47. By solving next circuit, that is let's consider this as VB. So applying nodal analysis, let's first divide the current I. This is I1, this is I2. I is equal to I1 plus I2. As I is flowing from here, 2 minus VB by 4 is equal to VB by 3 plus VB by 5. So after solving this, our VB value will be 30 by 47. So I2 will be 30 by 47 into 5, 6 times of 47. Now we got I2 current, I1 current. So I1 by I2 is equal to 6 times of 47 by 6 times of 47. That is 1. Hence reciprocity theorem is proved. In this circuit, we need to find the current I. So to finding this, we are using nodal analysis. So applying nodal analysis in this circuit. So let's consider this node voltage as VA and a ground voltage 0 voltage here. So let's divide the currents. So let's assume a current I1 is coming from here and dividing the current as I2, I3 and I4. As the 8 positive terminal is applied directly here, and it will be considered as 8 volts. From this, the current 1 amp is flowing here, as it indicates current source is in series in this branch, so we need to consider as 1 amp is divided here, and the remaining current is going in this direction, that is I3 minus 1. So next this 1 amp joining with I4, and current I plus I4 is flowing in this circuit. So from here, current I3 minus I1 coming from here, and when combining, both combined to form I is equal to I2 plus I3 minus 1. So this current combines and forms here. So apply a nodal analysis here. At VA, there are 4 branches. First branch, current is coming inwards, so 8 is first written, 8, or else we can write I1 is equal to I2 plus I3 plus I4. So I1 is 8 minus VA by 1 amp. I2 is VA by 1 amp. I2 current is voltage across this by 1 amp, plus I3 is difference of VA minus 8 volts by 1 amp, as there is an voltage is applied 8 volts here. I4 will be, as it is in a low voltage, so VA by 1 amp. So all denominators are same, so they will be cancelled out. So 8 minus VA is equal to VA plus VA minus 8 plus VA. All VS's, if you interchange, means 16 is equal to 1 2 3 4 VA. Then VA will be 16 by 4, that is 4 volts. So now we need to find current I. I is equal to I2 plus I3 minus 1. I2 is VA by 1 and I3 is VA minus 8 by 1 minus 1. I is equal to VA is 4 plus 4 minus 8 minus 1. That means 4 plus 4 8 minus 8 minus 1, that is I is equal to minus 1 amp. The answer is minus 1 ampere. Using nodal analysis, so let's consider this voltage as V. We need to find current at R2. This current we need to find. This let's take as I1. So total current is 0.04 Vx. One current is I1, another current is I2. So 0.04 Vx is equal to I1 plus I2, as it's a dependent current source. So Vx is equal to I1 is V by total resistance is 3 plus 5 8 plus I2 current is V minus current is flowing from here, V minus 60 by 5. So from Vx can be given as Vx. This branch total voltage is V. From voltage division rule, V into this same resistance by sum of resistances. Vx can be written as V into 5 by 8. If we replace this 0.04 V times of 5 by 8 is equal to V by 8 plus V minus 60 by 5. So if we multiply 5 4 is 20, that means 0.2 V by 8 is equal to 40 5V plus 8V minus 48V. So 8 ones 8 5s 10. V is equal to 5V plus 8V minus 48V. As we see, this is not volts, this is 0. 8 times of 60 480. So we interchange the LHS RHS and all writing V's in same RHS minus V. So 480 is equal to 12V. Total node voltage is 480 by 12, that is 40 volts. Now total voltage is 40. So current I1 will be total volt by total current, total resistance in this branch, that is 8. 40 by 8, that is 5 times 5 amps. So the current at R2 is 5 amps. In this circuit, consider the network shown with I1 or R1 is 1 ohms, R2 is 2 ohms and R3 is 3 ohms. In this circuit, a constant voltage is applied and need to find the current. So first we need to draw this equivalent circuit. In this circuit, if we draw a line across this circuit, this left side and right side looks to be symmetrical. That means left and right are mirror image to each other. R1 are connected here. The same R1 same R1 is also connected here. So R3 is connected to this terminal, R3 is connected to this terminal. So if the circuit having the mirror effect, then the voltage drop across these elements will be same. So if the voltage drop across R1, first R1 and this R1 are same, then the voltage potential at this point and this points will be same. So if these potentials are same, then the current flowing through this branch will be 0. Current will be 0. Similarly, same as in this also, the current will be 0 amps. So if the current is 0, then this, if the both potentials are same, then this can be a short circuit line. Treat this as a short circuit line. By considering this, and we rewrite the circuit. Then R1 as there is a short circuit. So we next in this node R1 is coming, and this is also a short circuit line. So R3 can be drawn here, and this R3 also can be drawn here, and last R1, and this is the short circuit line. So remaining only two resistances, R1, R3, R1. So if we apply, then 11 volts I will be flowing here. R1 is 1 ohm resistor, R3 is 3 ohm resistors, 1 ohm resistor, 1 ohm resistor and 1 ohm resistor. By combining all the three, we got the circuit as, I will draw like here. This 1 ampere will be 0.5 ohms, and here this 1 ampere is 0.5, 3 ampere is 0.15, 1.5, here is 0.5. This is the equivalent circuit. So now overallly this is 1, this will be R equivalent will be 1 plus, and this equivalent is 0.5 into 0.5 by 2, and that is 0.5 15 25 5 7. This can be written as 0.5 is 1 by 2 into 1 by 2 as it is, and 1.5 can be written as 3 by 2. So 1 plus 3 by 8. From this 8 by 8 plus 3 11. R equivalent is 11 by 8. So current will be V by R equivalent. Voltage is 11 and the equivalent is 11 by 8. This 11 cancel. Current is 8. So I is 8 amps.